Testing, 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 testing.
Hello, Mike.
Hi, hi. I thought for a second I might have had the wrong Zoom link.
I've had so many wrong meetings in my calendar that I was sure this one is right.
Yeah, nice to meet you.
Same here. This is my first time attending the call to get to fill up the discussion and see if I can contribute.
Hi, welcome. Which company are you from, Hamid?
I'm in transition. I used to be with Chevron, and now I have my own consulting firm until I land a full-time job somewhere else.
Very nice. My name is Mita Sagi, and I'm from Pure Storage. I'm just joining from a room that doesn't have my name on it.
Are you in Bay Area?
Yes, Santa Clara.
I'm in San Ramon.
Oh,
How's the
nice,
weather?
nice.
Cloudy?
The weather today is pretty nice, I think. I haven't really gone outside.
Yeah, we had the rain until Tuesday, but yesterday was sunny.
Yeah.
I see a user with room ID number, last name Martin.
Yes, that is the room I'm in. But my name is Mita Sagi, and I'm from Pure Storage.
Oh, I see. Okay. This is a good thing about the small meetings. You can get to know individuals.
Hello, everyone.
Hey,
There,
good afternoon.
How are you
last
doing?
meeting of the year. How about that?
Yeah,
It's been an eventful year. Good
it
year.
has.
Yeah,
Oh,
I'm in
yeah.
transition to pick up my kids from the last day of school.
Oh
That's why
wow,
I turned off my camera.
you're traveling?
Yeah, I'm in California and today is the last day.
Right, right, right. Same here. I'm in Texas. Today was the last day for my son as well. So yeah.
So, yeah, I have college students, so they finished a little earlier, but um, hey, if I'm dragging a little today, it's because I was up late last night, but last night I got CPRLive to process CPADs. So, um, I've taken the point 0.9 version of the RAS API spec, and I can generate random CPADs and parse them, and that we're going to put that into the demo we're building for RAS API. So the RAS API demo is coming along really, really well. We're up in, we have something to show to you very, very soon.
Very
That's
cool,
great.
Drew.
Burning the midnight oil like that.
Well, I
Like
just was in, like I
yeah,
had about 30 files that I'd modified, and it was, all in my head, and I didn't want to stop because it was
uh,
really hard to remember where I was. So,
it takes a certain amount of what do I say, patience or
lack of context
Hello?
swapping. It's like, like focus.
It's a little bit stronger
yes.
than fiction. It's like, that kind of a rabbit, I got to finish
Yes.
this way to get code working.
Yeah. And
Yeah.
it's pretty cool. So the demo that and I can run through the demo. I don't know if we want to do it quite yet because I don't think the 0.9 spec is out. But I was thinking as soon as the 0.9 spec is out, we can run through a demo here for how it works that reflects the 0.9 spec. And we're frantically trying to get it ready. Right now it's a little bit confusing. It's not quite as clear as we want. But as soon as we get it as clear as we think we need it, that it reflects the spec accurately, in other words, then our intent is to open source it for comment. And we'll open source it first to the RAS API working group, and then it'll be completely open to everyone.
Sounds good. And whatever doesn't work, you can always blame it on Rama. He's not on call, right?
Rama's here. It's Rama. Krishna is Rama's direct report, and she's the one writing a lot of it. So she and I and Carlos are having a blast right now because it's all coming together. The spec is published. We can, start making a fake redfish mapping for it. I'm extremely excited because we've been dreaming of this for years, and now I can run a demo in code that shows us spoofing an error using a CPAD, processing the error, generating another CPAD, getting the status of the CPAD back as an informational CPER, and processing that. So,
That's
Yeah,
like my
Drew and Krishna and Carlos. Yeah, we have internal reviews. Yeah, yesterday also. Yeah, we're putting a lot of effort. Thank you, Drew, Krishna, and Carlos. Yeah.
oh, it is so much fun. I'm really enjoying myself on this because we've been dreaming about it for years, and now it's finally working.
Yep. So 5 minutes, 6 minutes past. I see some new attendees here. Mike, Ahmed, Mukun, and I don't know who is SG. I think from Intel, right? So if you guys want to introduce yourselves, feel free.
Yes, that SG is me. This is Savita Gandikota. I'm sorry, I still didn't figure out how to add my name to Zoom. I will maybe figure it out during holidays.
You're from Intel, right?
Yes, I am from Intel, and I'm working on the GPU side of the architecture.
Savita, you said, right?
Savita, yes. And I also sent you an invitation or ask for access to the documents, Yogesh.
Yeah. I saw that. I was talking to, so I asked you, is that you, RAS API something? Reader?
No, that's not me. Yeah, that's not me.
Oh,
So
okay.
I have my first name versus last name.
Okay, I'll take
at intel.com.
best would be if you could use Intel's Google Apps license, then it will be just your Intel email. That's easiest.
Yeah, it is Intel email only.
Okay, I'll take a look.
Yeah, I got it approved. So
Okay.
yeah, it is my Intel email.
Yeah, it should go to everyone. So yeah, we'll take a look. And as soon as see it, I'll approve it. Welcome. And then we have Ahmed and Mike.
Yeah.
And
Hi. So it's Mike Bartol, and I, received this invitation. I'm really excited to attend and learn more. Memtech. What we're doing is, I'm the principal firmware and validation bring up for new silicon, and focused on the memory controllers and memory section. So what I'm really interested to learn here and be introduced is, how some of the processes that you have when during brand new silicon and that has new features and trying to get those into production and getting all the firmware that needs to be developed for lab related silicon test and how it integrates well into the final product, and being able to add features that would be very useful for out in the field and diagnostics and other sections of that, and how it would fit in. But yeah, really interested to see all the other team members here and learn more.
Yeah.
Yeah,
Welcome.
well,
So
yeah,
we
we met this company CEO at OCP, and I invite. Yeah.
Yeah, Mike, welcome. We are discussing a lot of pain points. We released the next 1.5 version of the spec recently. Feel free to take a look, but also wanted to mention to you, since you are working on memory controller firmware design, we do have another group which is attended by all the DRAM vendors, and we specifically talk about memory issues there, memory error logging, handling. It's called FMFM, Fleet Memory Fault Management. It meets on Tuesday morning every other week. So feel, I'll drop the link to that.
Thank you.
Also in the chat window. Yeah. So hopefully see you there also.
Perfect. Thank you.
Yeah, and I put links to a couple of the specs in the
Thank
chat.
you. Thanks.
I did not
Yeah.
put the meeting information. It takes me a little longer to find that, but
The group IO thing. So from there, basically we use group IO as a primary mean for all the communication, like meeting invites, links to various wikis and Google Drives, fast call recordings, all of that, polls and messaging. So join that. From there, you'll get all the information.
and I'll pull the groups IO things up momentarily.
Yeah, I did put for FMFM. And
You did. Oh, you beat me to it. Okay, great.
I can do hardware formatting also, but since he's already here, I think he probably is.
Nobody knows about it.
Yeah. Okay, I don't see Mukund, but Hamid, you're here.
Oh, sorry, that was me. I just my
you
son happened to use my laptop for his Zoom. So. Yeah, I changed it.
got one more. No, just kidding. Hamid, how about you? I didn't think we
Yes.
met before.
Sorry, I'm not on the camera. Still in a car. The school is out in a couple of minutes. Hamed Exir, I'm based in San Francisco Bay Area. I used to work for Chevron, working on electric vehicle lubricants and later on data center and immersion cooling. I'm very active in the cooling environment and work group, but I saw, because of my background in automotive and reliability testing, and especially the battery coolant, we were having some experience with the silicon oxycarbides, and I thought maybe I join and see what you guys are talking, what's on your mind, what are some pain point that I may contribute to. So happy to be here, and most of it time I'll just listen because kids will be around. I stay.
Yeah, welcome. Yeah, and a lot of what we're doing is present silicon related and how to deal with things going wrong in silicon. But I think that there's some cooling stuff we haven't explored yet. So stay tuned. I mean, well, we've got a list of topics that we're working on, and I'll put a link in that. But like we're looking at pain points and looking at things we need to work on as a group. And so, there may be some opportunities, and so, we may need your help making them now.
That would be great. I'm working on several white papers and base spec on the other side of the hall. if you think of OCP as a big conference.
Cool. Yeah. I suspect we know a lot of the same people. I've been talking to Microsoft's microfluidics team recently about how it affects reliability. So there's definitely some interesting stuff there.
Hey, Drew, what I was thinking, Drew, was what you started in Tracker in Excel is a very useful thing. And since people, are sometimes not able to join every week, how about we start with that every week, right? you flash it for like a minute so everyone sees what we talked about, where we are, what's on the agenda? Or do you have a list of for FMFM? I think you have a list of what's next. Did you create this for HWFM also?
It's in, the spreadsheet is a little bit of everything. I mean, like we have tabs for the different work groups.
Okay.
And so, sure, I think that's a great idea. We flash the tab up, and I'm putting a few more links in. So the future work stream topics is where we're planning things out. And then the last week we started talking about error injection, and so I pasted that document as well. But I'll flash the document you were talking about, Yogesh. That's a great idea. Give me a second, and it will be up shortly. Okay. So you can see the tabs for fleet memory fault. Well, this is hardware fault management. This forum, fleet memory fault management. RAS API is a CLA group, so you have to sign a contributor license agreement to join. It's open to anyone, but because we're developing a spec, you have to sign into it. You know, you have to agree that you're going to participate in the spec. SDC is a closed CLA group that is working on reducing data corruption. The GPU RAS is another closed CLA group, and then there's a CPU, and there's an open group and a closed group. And I'm less involved with the last with SDC and the CPU debug one. So I've got a few things in the sheet, but you know I don't have a lot of detail. And the other ones I'm more involved in, so I'm trying to keep them up to date. But I think we decided that error injection was a pretty big priority last time, and the other thing that we're trying to do is clean up severities. And so I need to I think what I'm going to do, Yogesh, is take that spreadsheet I made, and I need to factor it into the infrastructure requirements because there were some learnings. I most certainly learned a lot of new things as I worked on the severities. And then the other thing that I'd like to do is document what the severities mean a little bit. Like have that sheet as a document where things are explained a little bit. Because what I'm finding is a lot of people I work with end up being really glad to have it. And the spreadsheet I'm talking about is here. And so what I'm going to do is I'm going to put a link in the topic sheet.
Yeah, and what is also pending is the 1.5 version. We don't have a CPL link in the error taxonomy, right? CPL link in the sense we do not tie individual error types to which CPL type it is going to be, right?
Right, and I did that in that spreadsheet.
And spreadsheet solves that problem, so we need to finish that. So it's closed.
Yeah, well, and so I'd like to incorporate this in the document somehow, some way, and it can be I don't know what the answer is. It could be a separate document, or it could be like tied to that table and map there.
Yeah, I think that table is kind of our go-to direction to the industry about the error taxonomy. I think severities belong with the taxonomy, so I think we'll have to figure out a way to see how that could work. I'm not saying straightforward.
Yeah, well, I want to make sure this is documented and explained. So, but I'm not sure how. So we need something.
Yeah, it needs to work. Yeah. Okay. Thanks. Yeah.
Okay. And for those of you that have never seen this before, in the hardware fault management infrastructure, we described some severities. So I started with that list of severities that we had described in the doc. And then what I did is I looked at everyone else's severities and just tried to map them to the hardware fault management ones. And sometimes that people add more detail, like you can see there are multiple non-fatal recoverable, and so that detail became valuable. So anyway, I think the mapping is pretty much done, and I just need to document it. So I'll work on that some next year. And I don't know, Yogesh, I'll start writing, and then you can see if what I write goes in the fault management requirements or whether it's a separate doc. I don't know. We can do either.
Yeah, I'll be honest. I'll have to actually digest your spreadsheet. I have not done a thorough job of that, so I'll try to look at both and come up with some. And then after that, I'll discuss with you, and we'll come up with some way of kind of
Yeah.
the two. Okay.
Okay.
There's smoke downstairs. The alarm
Oh,
is
sorry.
going to be loud.
Yeah, I may have a fire alarm going off here. We have a Nest fire alarm, and it says it's clearing. Okay. I don't know. That was pretty wild. I don't know if you heard it. I got my taste. So it was like an office building where it broadcasted throughout the house that there was smoke, and the alarm was about to sound.
The rain one, and I changed some of the sensors so they don't only beep, but they also tell you, please evacuate. So,
That's what mine was doing. These are Nest fire alarms, so it was getting ready to tell us and it told us where the smoke was.
and then phone starts ringing because you get a call from the monitoring company. Like,
Oh, I don't have that, but
yeah.
but I was gonna have to go try to shut the thing up. I think they burned something down in the kitchen. Okay, so then I don't know what we want to look at, Yogesh. I mean, we can look at we can go back to the air injection requirements is what we were working on last week, and that's I was thinking we would also have Anil's got some stuff from LPDDR he may want to share.
You can ask him, but I thought Anil wanted to bring it to FMFM, or here is fine too, but that's what I thought at least. Anil?
Okay.
I mean, it's generic enough that we can cover both the places. Not all the audience are attending both the meetings.
Yeah, that's kind of what I was thinking too, Anil, but I don't know. I don't know what makes the most sense.
I'm fine either way. Whatever Anil decides.
Going to be loud.
Sorry, I'm getting yelled at again. Okay, well, if I drop suddenly, it's going to be me trying to deal with the fire alarm.
Yeah, no, don't worry. You do what you do. Go take a good look at it. Something's really burning. Anil, what do you say? Do you want to do you want to take up that topic today, or you want more time to prepare?
I mean, slides are already there, so if you guys want me to cover that, I can.
Yeah, I think that's.
Hey Yogesh, I missed. What is this topic? Like, I missed.
Anil, why don't you?
Yeah, no, I was wondering whether we wanted to continue the error injection requirements because we're already in the middle of it, right? Like. I mean, I'm okay with this also, but I wasn't sure whether that was a planned topic. But
we'll decide in a minute. What are you planning to cover in your you talk about LPDDR?
More of a the progress in the JEDEC that we are making to define the RAS coverage in LPDDR6, how we basically plan to improve it compared to what we had in LP5.
Oh, that sounds like a good topic.
Okay, and where did we leave last week on error injection, and what is next on that? Because I think we have some ARs, but
I can speak to that. We need to work on the use cases. That was the big thing, and so people were going to add use cases to the doc, and a few people did. So
Yeah. And also like our requirements are not very clear, right? Before even use cases, like we need some of the CSP requirements as to like what they like, what would they like to do with out of band, and will RAS API be the path for this? I think we haven't clarified the
Yeah.
hyperscaler requirements very well yet. I mean, yeah, go ahead.
What we should do is to add the requirements, not like line items, but actually as a table. What is the requirement, and then have at least 2 or 3 primary vectors, in-band, out-of-band, spoofing, real, firmware requirement or hardware requirement. Let's identify 2, 3 or 4 key vectors, and then start listing use cases.
Well, it's kind of the other way around, Yogesh. Like the use case is what are we trying to do? And then out of that use case come requirements, like what do you need to do it, right?
Okay, I was just trying to kind of address Shubha's concern, right? So just either way is fine. We reach the same conclusion. What needs to be done, but if you put it in detail, I mean, at least one thing becomes clear is the person who is putting in the requirement has to put some thought and list out some of the things with it.
Right. And also, like, I mean, the use cases for spoofing and injection, that seems like just one of the requirement, right? Because, platforms or vendors shall provide spoofing as well as error injection capability. That's your high level requirement that goes in the section above, right? And based on that, you're creating your use cases for spoofing and injection. So I feel that like we need to get some baseline requirements, that there should be security built around it, or like, just clarity. I know we have a list, but I think we haven't articulated that very
and we
well
haven't
yet.
clarified, we haven't clarified the use cases yet either. Like for instance, in the lab, the security requirements are vastly lower, but than in production. So like we'll have to figure that out. But I think as we clarify the use cases, then we can say, here's what we need for each one of them.
Do allow me to interrupt you, but I think what Shubha is asking is already listed. That's the high level requirement there, right? The OCP error injection requirements, that section above problem statement. That's what it is. But this section, this is really use case, technical requirements, not like high level requirement, right? So that's why to make it more technical, I still feel like we should have at least few vectors identified. Right.
A few identified?
A few vectors, right? How do we define like the requirement, right? How do we break it down, right? So what's needed? What does CSP need? What is expected from hardware? What are temporal requirement, like its development, its production, its lab, what nature, right? Those kind of things we will have to start identifying for technical stuff, right? The high level requirements are there, right? You already listed.
Exactly, like from a vendor perspective, right? Like when you tell me, like as a hyperscaler or CSP, that hey, in our fleet environment, we need these error injection capabilities, right? Then that's when we can, of course we have some, but we want to get a good list of requirements, changing requirements from you. So if we can articulate them, that would be great.
Rama.
Rama has his hand up.
No, yeah, I think your voice is a little faded.
So Rama, go ahead.
Yeah. Remember, like 2 weeks back, we presented hyperscaler requirements from other spec. Like, I think we can leverage some of that. It has the details of spoofing and other requirements, coverage and all. I think Vilas was asking, hey, there is a gap on certain aspects, right? That's where we want to cover, right? Like use cases and how do the tool API interfaces work and all, right? We can leverage we presented 2 weeks back and extend further if you see the gaps.
And Rama, the problem I have is I don't remember it as well because it's not on the same doc. Is it possible to to replicate those requirements here so that we can build on them or link them here or something?
You can hear or copy the thing.
Oh, I'm sorry, you broke up there.
Yeah, we can link the document or we can copy it here for completeness. Yeah, either thing works.
I think maybe copying it would be easier to read, and then we can say, okay, here's what we've got, and then here's what we want to add.
Yes.
And then and this can be just kind of temporary. And once we've nailed it, we can say refer to the other spec or maybe even update the other spec. But it'd just be easier to see it all in one place
Sure.
while we're scribbling.
Yeah, that 1.7 spec is released, right? We can put here. Yeah.
Okay.
So just a brief interruption. I think, Anil, what we'll do is we'll have your topic in upcoming meeting. Is it okay? I think we're already kind of started talk about this. Maybe put more structure around it. Is it okay if we talk about LPDDR in upcoming meeting?
Hey,
Yeah, that's fine.
Rajesh,
Yeah.
for LPDDR, won't it make sense to have it on the Tuesday FM where some of the other memory vendor folks are also there?
Yeah, I think Anil is going to do it there as well, both places.
I see. Okay.
And I've seen bits of what Anil's done, and I think it's kind of generally interesting. So it may be relevant. Like there are different people at the different meetings, and some of us go to both, but there are different people here too.
Okay.
Yeah, if there is less overlap, I can come there too, and then we can. Yeah, but if you're replicating just for few folks who are already attending there or not attending there.
Yeah, we can figure it.
Yeah.
So how do we go about capturing and solidifying 3 or 4, whatever number of tactical error injection use cases? Tactical in the sense, very practical, the full end-to-end recipe requirement sense, right? Not just high level, it should do this, but rather it more granular ingredient level expectations. How do we document that and then we prioritize?
Well, like I guess I was thinking this list is a little bit clearer here. The use cases. So we can talk about the different environments and different because like each of these need different things, slightly different things. So I was imagining, and I like this list. Like whoever added at scale. Oh, Suke did us a favor. Like at scale data tooling flows. That's a really good one. And debug issue reproduction. So I think this is a good list to start from. And then the requirements will vary. You need something different for at scale tooling flow than you do for in the lab testing. And unless I talk through those use cases, I can't just dump a coherent set of requirements to you. But if we walk through each of the use cases and say, I need this here, that here, we can find the patterns and build the requirements from there. Is kind of what I was. I'm just worried I can't give you the, just the full list.
I have a plan. Go ahead. Who's someone speaking?
Yeah, are you going to expose this to the end customers?
Well, we are the end customers, aren't we?
No, you are, but your customers. That's what I mean. The CS. Yeah.
Oh.
So will it go to the, whoever? I mean, there's Microsoft or the CSP itself, but
I think
but
you're
whoever
referring
is the
to-
user of it.
Yeah, you're referring to the end user, right? No.
End user, yes.
Yeah, error injections are not exposed to end users.
Okay.
So maybe that's one requirement to put
That
in,
is one
right? Like that.
requirement because we can have more stringent requirements from hardware point of view, where from a security flow, right?
And it's not a use case, right? It's a requirement that end user shall not be exposed to the error injection.
Yeah, it needs to be transparent to the end user. Absolutely.
Yeah.
All that has to be hidden away.
I think.
And
I think I don't want to make that as a sort of a hard. This is up to the CSP to make that decision, right? The intention is to not expose, So that how do we not expose is up to CSP how they do it.
So I think you can think of it as
implementation
having
dependent.
Right.
a-
I mean, what I'm
basically
saying is
having
from the vendor's point of view, right? When we are architecting the air injection flows, we don't want to put that as a hard requirement.
I see.
Otherwise,
Well, what we can say is must be able to prevent.
It will be, and so I think Sakul said the same thing. It is generally not available to all users. Special privileges as per the discretion of the vendor and the server fleet operator may be provided to various user levels. That's what we can say. But generally not available to everyone is what we can dictate right now.
Yeah, the other thing, it is ideally supported in certain maintenance mode or
Exactly. So
RMA.
we will have situations where we will have, okay, we need to work in this customer's production fleet. Let's have a three-way NDA. Let's go, let's either bring their, somehow release it to their fleet or whatever in a contained environment, in a controlled or remote kind of. There are a lot of various implementation details there that could. So let's not be like anything. We cannot be very rigid about it.
So I
Okay,
just
if you are going that route, then we have to introduce which error injections should or will be exposed, because that's a very important distinction. Especially in the VMs, if you're talking, there will be some hardware resources which are joined across VMs, right? Like a fabric or a memory controller. I mean, memory, that's a different, they will partition it, but things like fabric. If you are injecting error on one, definitely the other VMs would be corrupted or whatever can happen. So the interference part of it should be avoided. I mean, an easy way to do is like which error injections are allowed.
I think,
but we need to clarify
I'd
that.
like to keep it simpler than that, Savita, and that is that the air injection is generally not directly available to those end users, and if we decide to make it visible to them, it's something the cloud provider enables somehow, and we can control what they do. It may be that I have one customer that owns all the VMs on the machine, and I don't have to worry about that. I can just let the air injection through. So I think it might be better just to say, we have a way to pass it through if we want to.
I think one requirement that. Sorry.
I think in terms of that, so just one quick second, Anil, right? I think the important distinction there is a customer, if he is privileged with certain level of error injection, it should not affect other VMs which are which are not owned by him, right? So if a hypervisor level fabric application has to be done, then CSP will have to decide whether or not it is affecting one customer or more. And I think this generally should be owned by the CSP himself. CSP should not be given the one VM so much control that it can actually disrupt traffic to other VMs. That would not be a prudent cloud service provider policy, I think, in general.
Yeah.
Right?
And so that will be a requirement back to the CSP versus a vendor. So then now what we are talking is requirements both for hardware vendors and requirements for CSPs. Maybe that also we should document, or expectations out of CSP.
I think is we're going to propose a solution, and the solution will accommodate what it needs to work. But go ahead, Anil.
All right, please.
Yeah, I think in my mind, air injection, I think one of the fundamental requirement is the user who is using the air injection should have root access. So, and all the air injection tools that I know so far they require root access.
Yeah,
so from the VM point of view, it's really kind of orthogonal, because I don't know why would somebody inject error from a VM, or even if there is a need for it, right? That's I don't think any tool exists today that can be used.
And here's my proposal, Anil, is if someone some reason needed to, then maybe they pass a message to something more privileged, and the more privileged thing says, "Yeah, I'll do the error injection for you." You know, that we can handle it that way. But I'm with you. I'm
Yeah.
not.
So
You know,
I would, yeah. I basically what I'm saying is we at least the scope of the this error injection requirement, we should limit to having a root access for now, unless somebody comes back a very strong desire. Then then we need to architect a VM requesting the root to call an error injection, whatever the semaphore, and then from there the root daemon or some agent actually invoke the error injection then, and from there then it'll pass it into firmware. I mean, basically it's a hierarchical way to kind of then invoke the injection. But I don't see a need for it right now, and I don't want to, because that's a pretty complex, but yet another layer of implementation that we want to shy away from there.
well, but we do this all the time, right? Like I'll have a script that I'm doing memory error testing in, and it'll pass something to do it'll do an EINJ error injection. It's no big deal.
No, but Drew, error injection EINJ requires root access.
Right. But I'm saying that the software is running as user, but it has some way to communicate with something that does the EINJ. It's a well understood problem that we can build a driver or do something that allows something in user space to do things with that requires root access. And so, it's just we can solve that problem as a hyperscaler. I'm not like I'm agreeing with you, but I'm just saying if we need to do it as non-root, that is a common pattern, and we can find.
Yeah, there's a distinction, right? I mean, you're right. So part of that injection is to run some workload accessing that memory address to trigger the error, right? So there, yes, a user code maybe running in a VM, we need to launch, but that's from a user code trying to access the memory part, right? The actual error injection part, right? The actual error injection part is always going to be invoked through the root access.
So we don't need to auger in on that. But my point was that if that user application needs to inject an error at a certain time for its testing, it can pass a request to something running as root. And that something running as root can do the error injection. That is a super common pattern, right? That's what drivers do. Drivers allow user space to access something that has root privileges controls. And you can open up those controls to user space as you see fit. So it's a design pattern that's super well established. When you're fine, we'll do it as root, and we can, if we need to do something in user space, it can coordinate with a root agent.
Yeah. So basically, what you're saying is we don't need to standardize. We can just leave it up to the CSP to define a request to error injection from a virtual machine.
If we need an agent, we make an agent. Yeah.
I mean, yeah. So far we haven't done that, but yeah, if there's need for it, we can.
We've had drivers. We've done that before. I mean, we've had drivers that do error injection on behalf of a user process, and it's no big deal. It's done under very controlled environments, but it's required for testing certain things. So no big deal. We can do it.
Mm-hmm. So yeah, if you can put that requirement here, that error injection shall be done at the root access or the root level, then the concept of VM is really not.
I wrote that about I wrote a few minutes ago, but yeah, it's there.
Yeah.
Hopefully it shows up. Okay, so cool. You've been patiently waiting.
Yeah, appreciate it. So here, do we speak about physical access to device specifically for security related tests, like we want to change the voltage suddenly or add glitches on the voltage rail, on the frequency rails, or EMP pulses? So those kind of tests that injecting errors that break secure boot. So do you want to add some statements regarding that? But they need physical access to the device.
I'll just ask it as a question for now. I think it's more complicated. I think some voltage rails we shmoo and skew remotely. In fact, when it's in a thermal chamber and you're doing testing in a thermal chamber, you, by definition, do not have, full physical access. right? So, I mean, maybe you could run a wire into the chamber, but I think we need to discuss it. That's a complicated topic, but we generally don't want. We want to inject errors without physical access in many cases.
Yeah.
Yeah.
So
Only
I think
as
you're bringing a couple of topics here. Let's just kind of unwind that, right? So a cross section between a secure boot and error injection is a bigger topic. There's always a contention here that the secure boot mandate all the error injection should be disabled. Okay. I mean, that's like a norm, but we always have to kind of circle back. I mean, go around and poke some holes there so that we can still boot in the secure environment, but error injection is still available.
Yeah.
Right. So, but how do you do it? Right. It's still a very proprietary solution, and putting some standard would be useful. But let's put this in a to-do list because it's much more complex.
and I mean,
Now,
main aim being like when the CSP is qualifying the device, at that point, how does it qualify it that the device's handling of glitches on the rails or changing in frequencies is robust enough to be able to pass a secure boot, such that secure boot is not susceptible to these error injections or in fact fault injections during that point in time.
Yeah. So I think the second point is what you making a very good point, that we should have the requirement, right? We should have capability to create very low level faults. For example, over voltage, under voltage, over voltage, under voltage, over current, under current.
Yes.
In the case in the DDR5 when the PMIC was introduced, right? We actually created the whole PMIC error injection capability through our BMC, but invoked from the host. Of course, having a root access. But it was a very kind of proprietary way of creating the error injection for PMIC. If we can do some standardization there, like maybe invoking through EINJ or whatever methodology we define here, will be very useful.
Sakul and Anil, one question. I'm referring to the UEFI secure boot, booting to operating system. That is the contest or something else?
Yeah.
So maybe that too, or I was referring to more to the components secure boot itself. Example, if you have a memory controller, so when the memory controller boots up, that also has its own secure boot, its own measured boot attestation, measurements and all. So there itself, when it is booting up, if somebody glitches the voltage rails or changes the frequencies to beyond specs, so those attacks, I mean, how does the CSP qualify that? Is that in scope?
Yeah, I think it would be. And the way to look at it, Sakul, is it's one thing to have a machine in secure mode where you're doing the chain of trust, and it's another thing to trust the machine. And so if you have error injection enabled and you know you're doing funky things to the machine, it's in an untrusted state, but all the trusted stuff appears to work so that you can see that your error injection code can still log an error while you're in secure mode.
Why does it matter that we have to make sure it's enabled at the boot versus not? When won't it be just a command to go and enable error injection?
Yeah.
I mean, that is the most secure way, I would think, right? It's just one step. And anyway, this is a slow process. It's not like we are catching a bus.
No, but that's where the security comes into picture, right? Because you don't want a attacker to use that mechanism to as a exploit, right? Like you don't want to expose your error injection mechanism as a way to exploit. So that's why. I mean, the line becomes thin here, right?
But if it is the root, only root permission is the one we are granting. Only a user who has a root permission should be able to do this. No other user should be.
We don't trust the root user. That's the gist of it. So it is root, and that's part of the security, but we generally don't trust the root user either. And so what we typically do is we have a lock and unlock capability, and there's some cryptographic security associated with that unlock, and we can dig into what that means. But in production mode, when customers are using it, it is locked, and you can be root and you can be whatever, and the air injection is not going to work because we are protecting our customers. But then we can also have something in the fleet, like in production, where it's reserved by people that are doing testing. And that machine is not being used by customers, it's being used by someone internally. And there we might unlock it and do some funky things while running workloads on it to make sure that all of our air injection flows and analysis flows and error logging flows work while it's in the data center with all the data center tooling, but not running customer workload. So we'll dig into that, but that's a very key point, is that we need some sort of unlock, and it's not just a matter of being root.
Yeah.
Yeah.
Yes.
Right.
I think unlock and secure boot is two different things. Secure boot by like we enabled in Azure Fleet. I worked on it. It doesn't. Error injection still works. Okay, what Drew is talking, that makes sense. Where you have to unlock error injection capability. Secure boot, like even if let's say you enable it, if measurements failed with a firmware change, there is the option to like remove that node from production. I don't think secure boot with error injection has a problem. It's already enabled. Like we don't play with the lab nodes. Secure boot enable, disable, still error injection works already.
Exactly.
Whereas chip lock, unlock, error injection capability, that is different. That's where the GPU aspect has put some requirements already. Yeah.
Yeah, so I agree, and that's what I was trying to.
Yeah, it'll be good to just put the requirement here because Rama, what you're saying makes sense, but I don't think it's a like a general understanding. Like there are vendors who still think that we're going to we're going to disable error injection if the machine is booting in the secure environment.
Yeah, we can,
So,
but any spec doesn't say, like UEFI secure boot spec doesn't say it will disable the secure boot is just focused on the booting to OS from firmware to handoff. That is secure. You do the measurements and you verify the measurements. That's how you get the security. Yeah, we can. Anil, good point. We can add that configuration. Yeah.
right.
Yeah, and just as you mentioned, Rama, should we bring in the basic GPU error injection requirements that you have defined in that spec here, like as one of the baseline? Because I think they are defined pretty well, and it's not comprehensive. It's not like, it doesn't have all the requirements, but you had mentioned to use that as a starting point before, right? So maybe we can merge it in this document too.
Do to action item to copy the.
Yeah, that's
Yeah.
what we were talking about at the beginning of the meeting, Shabada, and he presented it earlier, so we're 100% aligned with you. That's a good point, and I think we all agree that's a good starting point for the discussion.
So one thing from a tactical point of view, right? One thing if we can do something here, is to come up with a little more tactical thing here. Like, should we standardize on and expanding the existing tool, like EINJ, for example, or should we define a complete new tooling method to have a sorry,
Rama, were you going to say something?
Yeah, Anil, I think like leveraging RAS API, maybe like extending on EINJ, that is the better option, because for GPU devices, EINJ doesn't work.
So
yeah, so that's what I'm saying. That so but it doesn't work today. But we can make that working, right? We can use the EINJ and extend it to PCI devices, and through PCI devices to within the devices, like internal errors, you can call that, and then expand that from there.
Well, and then like you can see here, we were talking about how we could use EINJ front end to a CPAD generator. So it generates whatever you need in the CPAD to trigger the error injection in the target. And so that may be one path. And then you might have EINJ on the machine as another path.
Right. So if we are all aligning that, okay, since EINJ already exists today in the industry, like just like a CPOR, right? We leverage on CPOR because CPOR has been there for a long time and people have been using it. So similarly, if we latch on to EINJ and just define what expansions we need in EINJ to cover various components, that would be one approach. Or if you say, no, EINJ is too restrictive and too archaic and we need to define and some fundamental limitations in there, and therefore we want to define a new method, then maybe that's another way to think about and then start defining that.
Yeah, and I guess I'm with you, Neil, and I think EINJ is kind of an interface that's worked well, but this green box may be off machine. So sometimes when you're doing testing, you have some sort of test coordinator that's driving things, and then you're saying, hey, did the device under test respond the way I expect? And so this CPAD generator could be on or off machine. It isn't clear. It could be either. And then the target obviously is on machine because it's the target. And so like we just got to figure that out. And we have another front end here too. You could have EINJ or another front end and to generate these CPADs.
Yeah. So this is a methodology to get the request to the host, and then from there onwards, right? The host will then do the EINJ call. Now EINJ
it may not be. No, that's kind of what I'm saying. If you look here carefully, the CPAD target is a RAS API endpoint. So I am not saying that we ever went through RAS EINJ at all. You could, if you sent this out of band, it could be, the RAS API endpoint could muck with the registers and do the error injection.
So basically what you're saying is that when it comes to the out of band, then we don't want to rely, there's no need for us to rely on EINJ. It should be yet another methodology to access the injection registers.
I mean, we could make the interface look common so that the software we use on the machine and off the machine looks similar, but the CPAD, the CPAD error injection generator, so I should be clear here, it could be it could be something completely different. It's not EINJ, but it speaks EINJ to some caller off machine or on machine. And the real question is, how do we communicate to PCIe devices? And so, that would even work on machine. You could have an EINJ-like interface on the machine that fabricated a CPAD that talked to the RAS API endpoint through the in-band path, and that would cause the card to inject the error. So from software's perspective, it looks like EINJ, but really it's RAS API behind the scenes.
I think so. I'm getting it. What you're saying, Andrew. This is still very high level, right? Technically, maybe short term, long term, maybe you can define that and build some commonality that will be more useful, right? Like
sure, yeah.
Yeah, I think we'll need to do some. I think right now we are kind of capturing a lot of ideas like we did in the beginning of the framework also. And we'll get to that point where we have things clearly segregated as they impact different parties, firmware, hardware, ingredients, and all that.
So just to be kind of,
we're at the point now to wish each other happy holidays and happy new year and pick it up here next year. It's been a great year. I thank you.
A lot done. Yeah.
Collaboration. Hey. Really enjoy this thing. Enjoy talking to all of you. So thank you for that.
Yeah, thank you. And if you look at what we did, the RAS API spec is almost out. We got the fleet memory management spec out, the Poison document, and we've got the 1.5 out. So there's been just huge amount of progress this year. So thanks everyone. It's really, really cool. Oh, and there was a GPU spec in there too, and an SDC one. So, pretty much all the work streams have published something recently. And some of these things are just things we've been working on for years. So it really is great to be working with you on this.
Yep.
Looking forward to meeting everyone next year.
Happy holidays. Thank you.
Yeah.
Happy holidays.
Indeed. Happy holidays. Thank you, everybody.
Yeah,
Happy
Bye.
thank
holidays.
you.
Bye.
Happy
Thank you,
holidays.
everyone. Bye.
Bye now. All right, Drew. All right, Mita.
Bye.
See, I hope to talk to you next year.
Yeah.
Yeah.
Bye,
Bye.
Sakul.
Bye-bye.
Thank you.
Thank you. Merry Christmas.
Bye.
Yes. Hey, Shubda. Hey, Shubda, if you're listening, I asked to send emails for Gus and Savita. I messaged her too. I don't see any requests from them. Okay.